Alright, so today we're going to talk about Cartesian coordinates. As the name suggests, they have to do with the Cartesian plane. And Cartesian plane is nothing but a fancy name for a 2D plane, which is represented, or rather defined, by two lines, x and y. The properties of these two lines are such that they cross each other at a point which we call the origin, and they are perpendicular to one another. That means they are at 90 degrees from one another. And with this description of what we call as a Cartesian plane, we can define a point, say point A. And we always define the position of the point in terms of how we can get to it starting from the origin. So I'm going to change my pen color to tell you how we actually start from the origin and end up at point A by the rules of the Cartesian plane. So the first rule is you always move in the horizontal direction first from the origin up to the point such that you're directly underneath A. So I drop a perpendicular right like so, and that gives me a point here. So I move this distance first, and I note how much distance I've moved. For example, let us assume that this distance is around 4 units, right? 4 units of distance in the horizontal direction. And as I reach this point, which is right underneath A, I move towards A along the vertical direction such that I'm moving parallel to the y-axis. So initially I was moving parallel to the x-axis, which was here, and then I moved parallel to the y-axis. Or initially I was moving away from the y-axis, and after that I was moving away from the x-axis, such that now my distance that I moved vertically is around 5 units. Let us assume that that's 5 units. So to describe the position of the point in terms of how we get to it from our well-known origin, I say that this point is represented by 4, 5. So for every point, first we write the distance that we move along the x-axis, and then we write the distance we move along the y-axis, and that gives us the complete description of where the point lies with respect to the origin. We can do this for any other point, like so, like the point P here, such that it is located at x, y from the origin. That is to say that if we drop a perpendicular from P to the x-axis, this distance is represented by our variable x, and this height is represented by our variable y, and that gives us the complete description of the point P. And using this simple description of representing points with respect to the origin, we can define every single point on the Cartesian plane, which may be here, which may be here, or which even may be there.